experience and making prediction based on the experience. A simple example we can say. So in a classroom, the teacher is teaching something to the students about some particular topic, so that students will learn from the teachers as something what they taught. Okay, so and the students can able to answer only what the teacher has taught. Okay, if somebody asks in different perspective, it can the students cannot able to answer. That's the thing. So they can learn from the experience. So machine learning is that they learn from the experience and making prediction based on the experience. Okay. Next is that. So machine learning types. So I just created some of the simple slogans here about this type. First is supervised learning. So supervised learning, we can say, it is
Gopika ma'am,
saying that,
sorry to interrupt. Ma'am,
okay,
ma'am, your voice is low, ma'am.
voice is very low.
Yeah, ma'am.
Okay. Okay. Is this audible now?
Yes, ma'am. It's
Is this
okay.
audible?
Yes, ma'am.
Is this audible now?
Now it's okay, ma'am.
Okay. So supervised learning. So we have a different type. So that is supervised learning, unsupervised learning, and reinforcement learning. So in this, the supervised learning, just informing us to say that it's trained. Okay. So we have to train the machine, and it act based on the training. Okay, based on the experience or based on the observation, it will perform it. Then if you go for the unsupervised learning, it just informs us to say that I'm self-sufficient in learning. So it just learn by its own. So there is a no concept of teaching and proclaiming here in unsupervised learning. Next is reinforcement learning. So it has a own life and own principles and own rules on it. So this is based on the hit and trial method. So I think you all know well familiar in chess. So if a person playing a chess continuously, they will learn a different. They know the different tactics in playing. They learn more experience. So everything is based on the experience by it now. So this is the reinforcement learning. I think this is a very trending concept. There's a reinforcement learning is. Next is the machine learning types and its use cases, everything. So if we go for machine learning, we have seen the three different types: unsupervised, supervised, reinforcement learning. In this unsupervised learning, that is the dimensionality reduction, clustering part, and it has some of the use cases like a big data, feature elicitation, structure discovery. Next, if we go for supervised learning, classification and regression. In this classification part, hope I think yesterday you have learned from the previous session. So it's specifically the image classification, diagnostic in a medical field. So it's highly, it is entirely based on there is a binary classification, categorical classification will be highly. And next is regression. So highly we are going to focus today on that is regression. Okay, these are the applications of this regression, that is advertising, popularity prediction, weather forecasting, market forecasting, estimating life expectancy, population growth prediction. You just listen that what is the there is a use cases here. Then we will see what is regression, what are things, other things. Next is we go for reinforcement learning. That is a real-time decision taken. So there is a car, automatic car, robot navigation, learning task, skill acquisitions, game in AI. So this is over under this reinforcement learning use cases. Okay. So this is a very simple pictorial representation of this supervised learning. So in this is the label data. So we are labeling each figures. There is a hexagon, square, triangle. So after we are feeding this as input and training the model. Okay, after training, we are giving the test data to the model. Okay, it just predict the model. So whether it is square or rectangle or some other thing. Okay, just do a prediction correctly. So the thing is, you just learn from the data what we preached here. Okay. Next is regression. Okay, before starting the regression, I will say that conceptually, that just consider you're owning a business. Okay. You're ready to sell one particular product. The product cost is rupees 10. Okay. So the people's purchases, the 10 members purchase this product. Okay. When the cost is rupees 10, 10 people purchase this product. Okay. Then you plan to increase the product cost. For 12 rupees, you have been increased. So now the purchase count has been reduced to only five members purchase this product. That is five. Okay. Then again, what we decided finally, you decided to set the product cost as 5 rupees. Okay. Now the purchase count is increased to 20. Here, from this example, what we are able to understand is, so the purchase count is only dependent on the, that is product cost. Okay, it can increase or decrease the purchase count is dependent on the product cost what we set. Okay, so that is the relationship between the uh, two variables. So that is said to be a regressions. Let's go with definition here. The statistical measure that determine the strength of the relationship between one dependent variable y, that is your purchase count, and another independent variables, that is your x1, x2, x3. Okay, so that is your product cost. Okay, so this is a basic definition. I hope you understand about this regression examples. What I said now. Okay, we will see in detail about independent variable and dependent variable. So we have to be clear with painting the graph here. So the variable we are trying to predict is said to be a dependent variable. Okay, so that is your purchase count. Okay, that is on that will be your y-axis. So it is denoted by y. Okay, some another example I had given, predict sales for the given level of advertising. I hope the y-axis will be obviously here. There is a sales. Okay, it is dependent on the real advertising. Okay, sales is dependent on advertising. Okay, so it can the sales cost will be increased or decreased. So it's entirely dependent on the advertising uh, part. Next is independent variable. So the variable we use to predict the dependent variable is said to be an independent variable. So it is denoted by x. Okay, that is the previous example. What I said, that is a product cost. So with the help of the product cost, they are doing a prediction of what is a purchase count. Okay. So here the x will be your advertising expenditure. The same example, the previous slide, what I told. This is a graph representation of regression. So you're having x-axis and y-axis, independent variable on x-axis and dependent variable on y-axis. So in this, here the data points, these are all, there is a data points. These are the data points. This is the linear regression line. So we have to find the relationship between this x-axis and y-axis. And finally, we have to draw a line. So that line is said to be a linear regression line. So if I conduct a regression, okay, I'm plotting some of the regression in a random play manner. So different data points will be stick over here. Okay, so which of the most data points crossed over this line? That line is said to be a best linear regression line. Okay, the simple linear regression. In this, you can say it's a term, simple, linear, multiple. So the graph will be a simple graph. So what is linear? What is a multiple concept? Okay, if it is simple in the case, it has a one dependent variable y and one independent variable x. Okay, linear. So linear, the line is linear in the case. The relationship is approximated using the straight line here. So the relationship here is we are finding the relationship between the x-axis and also the y-axis. So which of the approximated data points crossed over that straight line? Okay, that line is to be your best line to the best linear line. Then go with the multiple. So in this multiple, we have two or more independent variables, and we have a one dependent variable. Okay, one dependent variable on y-axis and two or more independent variable we will have. Okay, there is your multiple. Next is positive relationship. Okay. This in this positive relationship, x-axis your independent variable and y-axis your dependent variable. So the concept what I here is, if you spend more time on study, so automatically the grade will increase. So when x-axis get increased, automatically the y-axis also get increased. Okay, that's the thing. So then your graph will be moved to a positive manner. Okay, this relationship is said to be the relationship between the x-axis and the y-axis is said to be a positive relationship. Okay, I hope it's clear for you. And next is negative relationship. Okay, if you spend more time on social networking or messenger or something else, so automatically your grade will decrease. Okay, even if that your independent variable start increasing, and if your dependent variable get decreased, so at the time you will have a negative relationship. Okay, the relationship, the data points or something, everything will move downward. So you'll have a negative relationship. Next is regression. So regression is one of the, I think we are very clear with the basic concepts of this regression. Before that, we have here in this we are able to see different types of regressions. Okay, one, two, three, or more familiar and usable in our real-time environment. So each type they have a own significance. So depends upon the type of the data, and depending upon the data set, they will be using that is a type of the regressions. I think linear regression, logistic regression, and the polynomial is a highly usable. Okay, and the quantile this is based on the percentile manner. Okay, if sometimes if we go for like a cancerous, for cancer example, if the severity is higher in the case, the severe cancer disease severity is higher in the case, so it just show the percentage of it has a high percentage, and if it is low in the case, it represents some minimal percentage. It is based on the quantile manner. Next is rich regression, lasso, elastic net regression, principal component regression. Oh, principal component regression also in this. I think I hope not clear this about. Then partial least square regression also we have seen. Next is support vector regression, ordinal regression, Poisson regression, negative binomial regression, quasi-Poisson regression, Cox-net regressions. So there are many things are there. So in this Cox-net, I think it's very new. In this, it just predict the survival rate of the patients. Okay, especially this used in the medical field. Okay, this Cox-net regression here. Okay, these are the types. So we are going to see about linear regression. Okay, linear regression. So it is the simplest mathematical linear relationship between two variables x and y. Okay, that is said to be a linear regression. That is, the change in one variable make the reflection in the another variable. Okay, that is a linear regression example. So linear regression mathematical model. Okay, in this, y is equal to b naught plus b1 star x plus, that is the error variable. Okay, so this is equation. I hope from this you can able to see the equation, line equation. So anybody can answer what is the line equation? Any idea? Or I can post in chat. Okay, okay, I'll proceed. So y is equal to mx plus c. This is your line equation. Okay, y is your dependent variable, x is your independent variable, and b naught is your, if there is your y-intercept, and b1 is the slope of the line. This is your error variable. Okay, so in this, we will understand the linear regressions in what is happening. This is your black box of the linear regressions. So in black box, I hope you all know, we doesn't know what is happening in this. If you want to know, we have to study something. So we are going to see the black box of linear regressions, what is happening inside, how the steps is going on. So we are taking that is the X and Y, the random samples of X and Y. Okay, now we are going to draw a graph. Okay, so in this graph, it's the x-axis and y-axis. We are taking the value of x is equal to 1 and y is equal to 3. So we are plotting the point here, scatter plot. This is scatter plot. Has been plotted here over the graph. So this is this is the meeting point for here for the first two variables. Next is x is equal to 2 and y is equal to 4. So here this will be the meeting point, and x is equal to 3 and y is equal to 4. So this will be the meeting point, and x is equal to 4 and y is equal to 2. So this will be the meeting point, and next x is equal to 5 and y is equal to 5. I think hope you clear with this graph. So this is the drawn line. Okay. So the data points crossed here is the three lines has been crossed. So the equation is this is a line equation, y is equal to mx plus c. We know the y value and x value. Okay. We have to find m and c. Okay. For this we have to find that is the formula for m is summation of x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. Okay. In this, first we have to find the mean for x. X value. Okay. So the mean is 1 plus 2 plus 3 plus 4 plus 5. Okay, that is 15. 15 divided by 5. We're taking the mean, that is your value is 3. Next to 3 plus 4 plus 4, 2 plus 5, that is the value is 18. 18 divided by 5 is 3.6. In your calculator. Next is x minus x bar. Okay, so x minus x bar is, the x value is 1. Can anyone say what is x bar? Can anyone say what is x bar? Am I audible to you all? Okay, that is, you see, x minus x bar is, that is 1 minus 3. Okay, that is minus 2. 1 minus 3 is minus 2, and 2 minus 3 is minus 1, 3 minus 3 is 0, 4 minus 3 is 1, and 5 minus 3 is 2. Okay. That is your x bar is this value, 3 is your x bar, and y bar is 3.6. Now we are calculating this part, y minus y bar. Okay, so 3 minus 3.6 is minus 0.6, and 4 minus 3.6 is 0.4, the same value we get here, and 2, okay, next 5, the value is minus 1.6 and 1.2, and finally x minus x bar the whole square we are calculating. So this is the column, so we are squaring this column. So minus 2 the whole square is 4, minus 1 the whole square is 1, 0, 1 square, 2 square is 4. So we have calculated this part. Okay, we have to product these two values, x minus x bar into y minus y bar. Let's see what is it. So x minus x bar into y minus y bar. So we have to, after producting this, minus 2 into minus 0.6 is 1.2, and minus 1 into 0.4 is 0.4. Okay, so by this way we are calculating this column x minus x bar into y minus y bar. So after that we are taking summation of x minus x bar into y minus y bar here. For x minus x bar the whole square the value is 10, and for this value for the column x minus x bar and y minus y bar the value is 2 here. So we are applying for the n equation. So 2 divided by 10. The value is 0.2. Okay. Okay, now see that the y value 3.6, which is equal to 0.2 into 3 plus c. Okay, so the y here is, that is a here y bar you are applying, that is your y value, that is the mean of y, and x is, so that is your 3, and the n is, because we have calculated now, 2 divided by 10 is 0.2. So by this values we are evaluating the c. Okay, so the where is c here in this graph? Anyone can see? Any idea? Okay. You see in this y-axis, so the c, the point, the where in the point in the y-axis, so in which place it cuts, that the point is said to be a c. Okay, so these are all, that is the line, it is the m value. Okay, so the m may change. Okay, until it fit a straight line, best fit straight line, the m value will change continuously. Okay, so I think now we are clear about this part. Your m slope and c is a coefficient, x value, and finally we have evaluated the c value here. It is a final equation, y is equal to 0.2x plus 3. Okay. So we have completed here this part. We have to check whether this line is the best line or not. Okay, so this is a line we have been drawn. Okay, based on the input we have drawn. The thing is, we have to check whether this line is best or not. Okay, for that we are going into the concept of mean square error. Okay, so we are going to calculate the mean square error here. So we know the m value, c value, and we have the equation. For these values, the predicted value for the equation y, we are applying the x values 1, 2, 3, 4, 5. Okay, these are the values we are applying here. That is y is equal to 0.2x plus 3. We are applying the x values here. Okay, y is equal to 0.2 star 1 plus 3. So the equation is 3.2. So your asterisk, that is your multiplication. And the same thing we are applying for the all the values. For the x we are applying 1, 2, 3, 4, 5. So after calculating, we are getting the output like this: 3.2, 3.4, 3.6, 3.8, and 4.0. So these are the final values. So we are plotting the graph. So in this x-axis and y-axis, so this red points, so the red points we have circled here, or that is a predicted value. So the blue or actual value. The thing is, we have to find the difference between the actual value and predicted value. That is said to be an error. Okay, so that is an error. So the data points which overlapped in the case, so that is said to be a best accuracy or a best line there. Okay, so here it has been overlapped here, so it is a best point. And next is here, this is your predictor value, this is the actual value. So there is some difference will be here. Here we can say it is an error. Some minimal error will be there. Okay. So we are drawing a line finally. This is your line. This is a line of your regression. I hope this part is clear. So the mean square while we are calculating is whether the line is best line or not, we have to check. So we have to do this process continuously until you get a best line. So in your line, most of the data points should cross over. Okay. So when you reach that goal, you can stop the iterative process. By changing the value, you're changing the value here. No? X is equal to 1, 2, 3, 4, 5. You can exceed up to some value. So until you get the best fit line. Okay, until that you can do an iteration here. Next is R square. So in this R square, so we have find the best line now. Okay, So after finding the best line, we have to find the accuracy, whether the line we have predicted is the best line or not. So whether it reached the maximum accuracy or not. So we have to check here. So for that, the concept R square is used for us. So the R square value is a measure of how close the data is to fit the regression line. So that is your R square. Next is, it is also to be called as, there is a coefficient of determinations. So the formula for calculating the R square. This is specifically for calculating an accuracy. Calculating your, that is your best line. Okay, whether it reaches the maximum accuracy or not. So the formula for is summation of yp minus y bar the whole square divided by summation of y minus y bar the whole square. Okay. So we are going to calculate it. So for the, anyone can say what is yp here? I think we all know y bar, y minus y bar, or everything we know. So what is yp here? Any idea about yp? What is your y prediction? Yp is nothing but, so we have predicted this. This value is yp. Okay. Okay, we are going to do a calculation of R square. The random samples of same values x of x and y has been taken. So we are calculating y minus y bar. So I think y bar value is 3.63 minus 3.6. I will show it again. Okay, this is your 3.6 value. So this is your y bar. Okay. So y minus y bar, 3 minus 3.6 minus 0.6 and 4 minus 3.6 is 0.4. Like this way we are calculating all those columns. Next we are squaring this y minus y bar. So minus 0.6 we are squaring this is 0.36. 0.4 is 0.16. So we are squaring all the column. Next is yp. So yp is that is your the predicted value. Okay. Then yp minus y bar, that is 3.2 minus 3.6. So that is value is minus 0.4. 3.4 minus 3.6, that is minus 0.2. So by this way we are calculating yp minus y bar. And finally we are squaring yp minus y bar the whole square. So minus 0.4 the whole square is 0.16 minus 0.2 the whole square is 0.04. So we are calculating a mean x, y, and doing a summation of y minus y bar the whole square is 5.2, and yp minus y bar the whole square, the summation is 0.4. We have to add all those values of 0.16 plus 0.04 plus 0.04 plus 0.5. We are getting the value is 0.4. So now we are applying in all square. So 0.4 divided by 5.2. So what will be the answer? And please do a calculation in simple. 0.4 divided by 5.2. So that is your 0.08. Okay. So I think this is your accuracy. This is a very least accuracy. Okay, 0.08 is a very least accuracy. So it is not an 80%. So it is a 0.8%. Okay. So we have to need to do an iteration continuously to get a best line of regression. Okay. Until that we have to do. To reach a high accuracy, we have to iterate it continuously. Okay. Hope I'm clear about this. Next is salary prediction using a simple linear regression. Okay, so this is a case study we are going to see. So objective of this is to anticipate the pay of the workers dependent on the experience. The thing is, we have to predict the salary. Okay, so based on the experience, we have to predict the salary. So here we have to find what will be the independent variable and what will be the dependent variable. Everything we have to focus here. So these are the steps for linear regressions. Okay. In this linear regression, first we have to prepare the data set. Okay. So after that, we have to design the parameters. What is the parameters? So in this scenario, parameters in the case we can say there is a can be your age of the person, or there is a next to your salary, experience, salary, and the current salary, experience. So these are the parameters. Okay, among the different parameters, we have fixed what is x and what is y, what is dependent variable and what is independent variable. Okay, we have to decide the parameters. Next is preparing the training data and preparing the testing data. So we have to check for the total data set count and do a partitioning of a training and testing. Okay. Next is after splitting the data into training and testing, you are building the model here. Okay. So after building the model, we have to train the model with some algorithm. Here there is a linear regression algorithm. So we have to train the algorithm. After that, we are making a predictions. Okay. So we're doing a prediction about whether the model is working correctly or not. The what we have developed is predicting correctly or not. Then after the evaluation metrics and cross section, I think we have seen the mean square error and R square. For one is to check there is an error, that is your mean square error. Next is for accuracy, that is your R square. That is your evaluation metrics here. Okay, and one more thing, the next case study is COVID-19 outbreak prediction. Some key ideas that maybe in future I think will be useful for you. Okay, this is some two different concepts I have texted here. So I think COVID-19 is the most trending topic now. We all know from overall this, what is the use case of this regression is only there is a two terms. One is prediction and next is forecasting. So the major use cases of this regression is prediction and forecasting. Okay, from this way, so the COVID-19 is this regression is highly now more compatible with the trending and to the highly infectious disease of COVID-19 now. I think all are familiar with this COVID, the novel coronavirus. I think it's dissolved in the late 2019 in China. And this virus is said to be zoonotic disease, actually. So it spreads from there is animals to humans and humans to human transmissions. Now I think spread all over the country, and now it is in India also emerging very high, and many mortality rate, so everything is becoming more high nowadays. For this, what I'm saying here, how it is related. So to determine the transmission rate of infectious disease per day by a suspectable morbidity individual, is just think a person who is affected with COVID-19. Okay, if the person is loitering outside or coming outside in case with the social area, what it happens? So the spread, the transmission rate per day because of one person will be how much? So we have to calculate that. So how will be the transmission rate? We have to predict it here. So that's the thing. So after doing this, we can find that there is a recovery rate with the available data set. We can calculate the recovery rate and your death rate, mortality rate, your contact rate. So if the person is contacting multiple persons in it, how far it for like an assumption we have to do it. Okay, so contact rate is evaluated by considering the impact of interventions on the epidemic. Okay, there is a prediction and transmission of COVID-19 for the deceased person. Okay, and for the deceased person in the case, if the person is already affected by the diabetics or some heart disease already, or some like a lung disease or something else in case, so how far it is affected and how the transmission rate for that people. If we can do anything in the future, this concept is useful for you. Next is convalescent plasma antibodies prediction. In this concept, convalescent plasma, I think convalescent plasma therapy. Plasma therapy is, I think we all know about this. So the person who has recovered from the COVID-19, so the antibodies will be developed inside their body. Okay, so we have to predict here what will be the maximum reproduction rate of antibodies in their body. Okay, so so they will have some maximum antibodies for this type of age and the type of the age and the minimum the depends upon the blood count. Okay, what will be the antibodies developed? So what will be the reproduction rate of this antibodies? We have to check for the convalescent persons and how quantum level of antibodies can be taken from them. You just think with the person, the development of antibodies is also just considered that it is 80% in the case. So minimum level of 30% is only available, is possible to take. Okay, so we cannot able to take the complete part. Okay, so because he is a convalescent patients. Okay, just now recovered for patients actually. That's the thing. These are two key ideas. Okay, these are question answers. Any doubts on this? Okay, number I will move into the coding part. So today I'm going to work with you in that is in Google Colab. I request everyone to open the Google Colab. So just open the Google. So by using any of your Gmail account, please open this Google Colab. Okay, I will say about Google Colab first. What is Google Colab here? There is a collaboration of different packages or different software packages or different dependency packages. You can use the Google Colab. So it is a free cloud service provided by the Google. Okay. So if you install any of the packages on your local machine, so it just asks for the dependency packages while installing. Okay. So after if you are using so if you with the different use cases, it just asks for different dependency packages continuously. Some people, if you go and work with a different data set or with a high data set like a 10,000 or something else, at that time you need a there is a large storage and also there is a high GPU. So it doesn't work on the CPU at that time. So at the time you will be working on with the GPU. If you are using GPU in the case, the cost will be very high. If it is a laptop or going with the system in the case, you need a high-end GPU. For that, this Google Colab is very useful because only thing we need there is a very good internet connection. That's all, and we don't need to install any of the packages here. Your server, the programs, what you are typing, everything will be running on the Google server. And next part is the installation part. There is no part of installation here. Okay. So this is your Google Colab. So please do log in your any of your Gmail account, okay, and give a new notebook. So the codings will be similar. Okay, it's not that much difference. The persons who are using the Jupyter notebook and its spider and everything, it will not have that much difference. More or less, it will be similar only. Okay. The thing is, we are working here in that is your system in your with browser with the Google browser. You will be working on the local machine offline. You will be working here is online. So I'm opening So I will say what are the basic things first of all about this usage or something else, but then we will enter into the coding. Okay, I have opened a new file. Okay, so this is your name. Salary underscore experience. This is your name of your notebook. Okay, salary underscore experience prediction. This is the part. So in this, um, we are going to write that is a basic libraries first. Okay, import numpy, numpy as np. Okay, this numpy np, I think this is your libraries. Okay, there is a basic libraries for the most of the part, most of the programs. This will be the basic library here. So give control enter. So you see the message here, there is a connecting, allocating. So when you start executing that, you just allocate a specific space on the Google server and this part will be executing. Okay. Okay. Then I will just open the notebook here. Okay, thanks for your answers. I'm seeing the Marshall Mano for the equation, line equation, and the Manjula K for the mean value for the x. Thank you so much. Okay. So first thing is we are going to see two different case studies. The first case study is that is your prediction part, linear regression concept. The salary based on the experience prediction. And second part is COVID-19. So COVID-19 forecasting part, that is like a 7 days or 10 days with having some data set with me. I will share with you. So import numpy as NP, and next is import matplotlib.pyplot as PLT. Next import pandas as PV. Okay, these are the basic libraries we are importing here. In this next part, we have to read the CSV file. I hope the data set will be in the format of CSV file. So we are importing the data from the measurement or something, some places where I have stored. Here, I'm going to show you how to upload this. So I'm executing this first part. So it is connecting. Initializing, connecting. So it has been executed. So the RAM and disk has been allocated for you. You can able to see some of the details around this. You want to see something. Okay, next is we are going to read the CSV file. That is PD is equal to df is equal to pd dot read CSV. We are going to read the CSV file by using an library pandas pd. Okay, so after reading this part, so the data will be stored in the that is a variable df. Okay, df is variable. Df part. Okay, we just imagine this like a storage or something. Okay, I will say how to upload this. Just go ahead, just click on these files and click on upload to the session storage. This desk, taking a salary data. So here it just showing us some message dialog here. That is reminder, uploaded files will get deleted when the runtime is recycled here. So what is trying to say here is, so the data what we have uploaded here will remain exist only for that is 4 to 5 years. Okay, so up to 12 hours it remains the coding, every part can able to execute it. So if you want to execute again and again, so you have to upload each time. So this is a temporary upload. Okay, now I hope this part is clear now. So now salary data.csv. So sometimes you may write an error like uppercase error, lowercase error. The file will not reflect in this coding part. For that, you can it's a better way to copy the part and so everything here. This is your root. So in this root directory, in the content folder, you are having salary data.csv. Okay, we are executing this part. Next is df.head. So what is this head part? So anyone can say what is head here? Head part. So head in the case that is in Linux, they will be using this command. That is a head part and tail part. So while they want to see that is runtime machines, what are the machines or using the dynamic IP and something else. For that, they will be using this command like a head and tail. So the head, it represents just displays the top 5 data. Okay. So df.head in the case that is displays the top 5 data. If we go for df.tail, last 5 data will be displayed here. Okay. So df.head. So the first 5 data has been displayed. df.tail. So last 5 data has been displayed. So next is df. In df, now we are very clear. We are having all the data in the df. Okay. So the data contained is years salary, years experience and salary. This is the data stored inside this df. So now we have to check whether any null value exists in this column or not, in this data set or not. So we have to check. If any null value exists in the case, we have to fix it. Okay, so fix it. If not in the case, we can continue. For that, we are checking here df dot is null. Whether we are checking is null or not. Dot sum. So there is no null value, nothing. So you are proceeding to the next part. So no need to worry about this changes of null part. Next is if you want to display the top 10 data in the case, so df dot head of 10. Okay, the top 10 data will be displayed here. So after this part, we are splitting the data into two. Okay, that is uh, which will be your x value and which will be your y value. Any idea? Can anyone say which is x part and which is your y part, please? So in this data set, which is your x and which is your y, which is your dependent variable and which is your independent variable? Can anyone answer? What is it? X is yes, yes, good. Okay, okay, thank you. RK, I didn't know the name. What is there? RK promote. Okay, okay, it's right answer. Okay, So x bar d, dependent variable will be, that is your salary will be on x-axis. That is your independent. So the experience will be your x-axis, and salary will be your y-axis. Okay. Now x is equal to df. Now we are containing the data part. Okay. Df dot iloc. Iloc is, that is the index location of, that is colon comma 0. So this colon, what does it says? Uh, that is, it start from the first row to last row. It has to print. Okay. So the column is 0th column. So they are mentioning. So we just do an evaluation and store it in the x. Next is for y. So the df dot ilog colon comma 1. Okay. So all the 30 rows comma the first column. So that has been stored in y. Okay. Just see the x value. Sorry, we didn't execute this part. Okay, this is your x part. So the 30 rows starting from 0 to 29, and your years of experience has been displayed. After that, you calculate y value. Okay. This is your salary part. Next is you have to shape the data. Okay, why is there to shape the data? Okay, so we have to, in linear regression, we have to shape the data. We have to say these are the rows and these are the columns. So they should be in x-axis and they should be in y-axis. We have to define it very precisely. Okay, so x dot shape. Okay, I will execute this part. Just see. So what is there? So 30 comma 1. So here. So 30 comma, so 30 comma nothing. Okay, we have to change this part to 30 comma 1. Okay, that is 30 rows with first column. So 30 rows with 0 column. We have to reshape the data here. So we have to fill the data. You see, this is incomplete. X dot shape is incomplete here. So what we have to do, we are typing, we have to check the type of x first of all. So the type of x. So the type of x, it is in series format. Okay. I can show to you. In this reshaping, x is equal to x dot reshape minus 1 comma 1 and y is equal to y dot reshape minus 1 comma 1. We have defined here. So minus 1 comma minus 1, it represents here, that is len of dm, or len of df is that is your 30. I think I have written here. So len of df is 30. You can write that also. Otherwise, you can write 30, or here you can write minus 1. So while executing this data, so it just shows an error. The series object has no attribute ratio. Okay. So the concept of reshape will not reflect, will not work on the series. Okay. For that scenario, we have to change the series into an array format now. Okay. Now, for this, x is equal to df dot ilog colon comma 0. That is your 30 comma 0, your first column. Here we have to add simply dot values. So this, what does it do? It just convert the series into array. Convert series into array. So we are executing now. Okay, after execution, you see. So now the type of x is md.array. So we are checking whether this reshape is working or not. You see, this will be like this. So 30 rows are printed. The first column is printed. So 30 comma 1. So now we are executing this reshape part. So after converting the series to array, the reshape part will work here. So after finishing that, so now we have to split the data into training part and testing part. Okay. In the basic scenario of splitting the data into training and testing, so we have the scenarios of that is splitting the data into 80-20 part, or there is a 75-25% or 70% 30%. So depends upon the data set. So the splitting concept will work out. So here I'm using here from sklearn. So scikit-learn. I think this is your one of the library here. So the model what we are going to select in this. So from sklearn dot you are going to selection. So what in this sklearn we are using a specific part of model selection. So in this model selection we are importing train test split. So this is specifically used for training and testing. Okay, this is an for specifically for this training and testing. So in this part, the X train, Y train, X test, Y test. So it has been divided. Here, you just imagine we have 30 data. In our scenario, we have 30 data, 30 samples. So in this 75 percentage of 30 samples would be how much? Any idea? Anybody else? What is the count? 75 percentage of 30 samples will be how much? 23, 23, 22. Okay, so 22. And your 8 value will be your testing part. So 22 will be your training part, and 8 will be your testing part. Okay, so X train, comma X test, Y train, comma Y test. So we are splitting. So then next is train test split. Okay, these are the where we have imported this part for training and testing. So we are saying that X value and Y value by taking this. So dividing, so you are saying the test size of 0.25. So why you are saying this 0.25 is that is your test data size. It should be a 25 percentage. Okay, so 75 percentage of 30 samples is 22, and your test size will be that is 25 percentage. So I'm mentioning here is 8 data will be your test data here. So that is 0.25. So I'm checking for length of that is the row of how many data are there in extreme. You see, sorry, I didn't execute this part. So it's 22. Okay, len of Y train. This is also 22. Okay. So what will be the X test and Y test? Anyone can guess? What will be the len of X test and Y test? What answer? Yeah, thank you, Arti. Balvinai. Yes. Okay. So next is len of X test is 8. The right answer. And len of Y test also 8. Okay. Now we have split the data. So what we have done, just imagine it from the starting. You're reading the CSV file. We are seeing the data. We are allocating the X variable and Y variable. After that, we are shaping the data. That's all. Then after that, we are splitting the data. Okay. So the training part, we have divided the training part and testing part has been over. Now, next is what we are going to do is Just check the X test. So the 8 data. So the data the taken from the data set, so will be a random value will be taken. It is not a continuous value. So if it is a training data, it has to take from the first row to 22nd row. It doesn't mean that. It just take any random value out of this 30. Just take any random value and do a print. Okay. So by this way, the excess data I have shown it here for you. Okay. Next, we are going to use an algorithm. For algorithm, I'm using a linear regression algorithm. So from the library, sklearn library, we are using the model, linear model. In this linear model, so the term linear regression algorithm is there. We are importing this linear regression. So we are creating an object for linear regression. So model is equal to linear regression. And executing here. Next is we have to train the model. Okay. Now the algorithm has been chosen. That is a linear regression algorithm. Now we have to train the model. Okay. For this model dot fit. Okay. What is fit here? Wherever you see the term fit in any algorithm, it does mean that. So just training the data, training the model. That is to be fit. So we have to make them to train it. Okay. So model dot fit. Okay, we are going to train X train comma Y train. I think in this board we have 22 samples, 22 samples check. Okay, so we have executed. Then after this, so after training, we are going for that is a prediction. Okay, widespread. Widespread is for that is a for predicting our model. Okay, so model dot predict. Okay, in this we are giving a test data X test where we having 8. Okay, the count of 8 we are having. So we are giving and testing inside this model. Okay, so the result will be stored in the white thread. Okay. Okay, this will be your output. Okay, X test. So this is all your salary. Okay. Next is Y test. Just showing to you what is a Y test here. So if you see this is more or less nearly to that value. Okay, that is 60, 63,000 to 280, nearly to that value we will have. Next. So the calculation has been run. The prediction part has been over. So after that, we got something. Now we have to check whether it reached an accuracy. Okay, for that from sklearn we are using a matrix here. So we are importing. I think we have seen the slide to check an accuracy, maximum accuracy. So we go for R2 square. So I'm importing an R2 square. This is a matrix in scikit-learn. Okay. So in this R2 square, the parameters I have to pass is y test comma y predictor. Okay. So the y test here is the value. It is actually y predictor is predicted value. So doing a prediction to the finally, we will see what is the accuracy now. Importing R2 square. Okay, the accuracy is 95% accuracy we are getting. Next is we have calculated error. So the difference between the actual value and predicted value, that is there will be an error here. For this, the metrics we are using from the scikit-learners mean squared error. Okay, this is an inbuilt one. mean square error like R2 square, mean square error. So everything there under metrics is type level. Okay. In this, the mean squared error is we are predicting the actual value and predicted values. So that will be your error. Okay. So mean square error is calculated. Okay. We have some values here. Okay. Next is, so after doing all this process, we are going to plot a graph over the scatter plot here. So in this plt.scatter, I think we have used the library matplotlib.py plot here. So I'm using here a plot plt.scatter. In this, I'm going to draw a regression graph for the training data set. Okay, so plt.scatter extreme comma y train. So the color is a very color you can give. Then plt.plot extreme comma model.predict. Okay, so we're going to predict the model in extreme. Okay, the color we are giving is red. This part will be your regression line here. Okay, this is your data points. Okay, so the training data. So it just the places the data points is scattered over the graph here. Next, plt dot shows just for showing your data. Okay, this will be a graph. Okay, we have to see which will show the data points crossed over this line, this regression line. So the data points which crossed most of the line, that is the of the best line. Okay, now we will check for our predictor data, your testing data. So in this testing part, so plt.scatter x-test comma y-test. So here in this previous part, we have given our training data X train and Y train. Now here we are giving our X test and Y test here. Okay. So plt dot plot, we are giving a test X test, that is the 8 values, 8 count values here. So just predicting. So this is your regression line and this is your data points for the X test and Y test. So you can see that now. Okay. This will be a graph, scatter plot graph. Here, I think it crossed the data points. The line has crossed most of the 3 points. I think. I think hope the accuracy. I think in this scenario we have reached 95% accuracy in this data set. Okay. So for slope and intercept. So this is m is equal to model dot coefficient and n is equal to model dot intercept. So it's do an evaluation interior and just show us what is the n value and what is the c value here. See, this is your n value and this is your c value. Okay, so we are going to apply this in your equation. You see, here the value has been changed now. So c value is 28109 and your n value is 9083. So we are calculating this part. Okay, we have executed. So now we are applying we are applying a 30. We are applying the value for x we are going to apply. That is, you just consider your experience is of 30 or something else. So M star 30 plus C. You see the output will be varying now. Okay. So 3 lakh of something value you are getting. So this will be your salary part. Okay. So based on the experience, the salary has been better. Okay. I think this is your linear regression salary. Salary come with your experience part. Here we have predicted the salary based on the experience. So under the concept of linear regressions, I hope it's clear for you. Okay, any doubts in the case you can post in the chat. I will reply for you people. If it is okay, shall I proceed to COVID-19 forecasting? If you are okay and you're clear with this topic, shall I proceed to forecasting? COVID-19 forecasting coding part. Okay, I will share the link to you. Okay, finally I will do a sharing part. Okay, this is your COVID-19 July. So the file name I have created here. So this is specifically designed for forecasting the data for the next 7 days. I think everyone knows there's like a weather forecasting, that is a disease growth, how it will be. So many forecasting is there. Like same as that of we are going to predict for the next 7 days how the growth will be, how the disease will get affected, how many people will be affected, and the range we are going to see here. So for this, so the basic libraries we are importing here, that is import numpy is numpy, founders of query. So you can, instead of this empty, you can use your name also. So this is called usage in your program, which for user no need to use each time as numpy. Instead of using this as empty, numpy is empty, and import cborn as SNS for graph purpose, for scatter graph, for anything. And for this also matplotlib.pyplot as PLT. This is the basic libraries we are using. Okay, just initializing, connected. Okay. So next is we are importing the path. So the path is same. I'm importing, upload, COVID world data. This is my data set. Selecting here. Okay, just uploading now. We can do, and that is your permanent upload also. You can upload and store it in your Google Drive, and you can execute like that way also. So it will not get deleted. So for each time, if you want to do this in the case, it will be difficult for you sometimes. If you want to do some real project or something else, it's better to go with there is a permanent upload. Okay, so in a drive, or some concept is also there like a mount drive. Okay, so we are mounting the drive. So if these options, we are mounting the drive and we can upload the data. Okay. Still isn't still uploading. A little bit it's the network issue, I think so. Okay. So in this, the concept of reading a CSV file. In this part, I think your file name will be stored here. Okay, let me open a new file. Okay, excuse me for this. I'm going for that. It's connecting. Upload the data. It's uploading. Okay, we got the CSV file. Copying the path and just do paste on this path and executing. And after that, we are reading the CSV file and storing it in the term that is df and using df.head to display the top 5 data here. So these are the data set appearance. It is represented in the data frame here. So the thing is, we have that is many columns here. In the province or state, we have many null values. Okay, so it doesn't represent something here. Okay, for that, I think this is not needed. In this scenario, this province or state is not needed. Okay, we are not going to use something else with these province or state here. So I'm deleting df dot in this column. This is your df dot. We are going to drop. Drop is nothing but delete. Okay, delete this column, province or state. So please use correctly this part. Okay, this is your uppercase or lowercase everything. Please state it, what is there in your data frame. Comma x is equal to 1, comma in place is equal to 2. So in this part, what we are saying here is, so if we deleted in the case, so the axis has to move to the previous part. Okay, so that is axis equal to 1 and in place is equal to 2. So after executing this part, we can see the output. So how the index has been moved to, that is a previous part. So in the place of province or state. Okay. So that's the thing. Now we can able to see. So the column of province or state has been deleted. So the country or the region has been moved to the previous axis now. Okay, this is the region. Now, if you want to rename, that is a column in the case, df is equal to df, your data frame is your data frame dot rename. Okay, rename of which column we are going to rename. Okay, we have named the column country or region. the same data within inside the codes we are writing. So what to be changed? That should be in the second part. So colon, there is your country. This should be changed in the country or region. That should be changed to country. Okay, we are renaming it here. So we are executing this part, and again executing df.head. Okay. Now we can able to see it has been changed to country. Country or region has been changed to country. So this is a way of renaming. Next is active. Okay. So the formula or some concepts to find an active cases is df of confirmed cases minus df of recovered and df of death. That we are, after evaluating, we can able to find the active cases. Okay. So the formula I have created. I'm executing this part. Next. So I'm applying this active in df of active. So df of active is the case. So in the df frame, we will get an one more column as active. Okay. So that you can see that. Okay. A new column has been added as active. This equals active. The last date we have specified here is the date. So the last part data has been displayed here. In this, the data is up to, that is 28 April 2020, up to the data set, this corona data set of confirmed death and recovered cases. The data is up to 28 is there. So that's why I displayed this df page here. Next is df.info. So in this df.info part, so the df is as your data frame. So I needed a little specific detailed information about this df. So each column, what is the data type of each column? So the country is object, and the latitude, longitude, and everything is there. So here what we are going to do is, the main thing we needed for this is, for forecasting this. So I have chosen choose the dated confirmed recovered. So here the date is represented in a form of object. Object is nothing like a string. The string is there. Okay, so we have to make a change here as a date format. Okay, so df of date. Okay, in the data frame we had a column date. Okay, so in this we are using pandas series to convert this to this object to date time. Okay, so date time of, again we have to specify which column, df of date. Okay, now I am executing this part. Okay, I'm displaying df.head. Okay, top 5 data has been displayed. So um, your uh, your object, we will check it again now. Okay, now we can able to see the object type is converted into date time. Okay, so we are going to do a forecasting based on the date. Okay, based on the specific date or specific period of time, how the death rate has been increased. So what are the confirmed cases we are going to see here? So that's why I have changed the format data type into a date time format. Next is, I'm defining a variable. So df of df of date, which is equal to df of date dot max. Okay, in this I'm executing this part and storing within the term top and displaying this part. In this here, the maximum date. So maximum date will be displayed here. There is a 20, as I said before, this 20, 2020 is the last day. If I want to do a forecasting in case, I will do for the result next or 7 days or 10 days or something else. So I can do. So I have to check the last day, so maximum day. For that one day, this is the statement here. I am evaluating and storing the data of top. Then after that, after executing this part, next is group by. So in this group by data, we know that in top we have this part. Data set we have this part. So in this top, we are going to group by. So by this format, so the content will be displayed. Okay. So by based on the country. So country is the main part here. So in this, what is the confirmed cases? What are the active cases, recovered cases, death cases will be displayed. Dot sum. Dot sum in the case that is a total value. So the total value of confirmed cases, the total value of active cases will be there. Dot reset index. So we are executing this world part. See. So by based, the country is a major thing here. So in this country, what are the confirmed cases? Because we have calculated the sum. So the reason index is to fix it in the specific column. To fix it in the confirmed cases or fix it in the active cases. It has to be set in the specific positions after summing. So that's why I'm using here dot sum dot reset index. Confirm active cases recovered and death. So this has been done by using the concept of group by here. Then after that, I'm just moving to the next part. So we are going to plot the graph. There is a word by confirmed cases versus date here. So by here date is a major thing. By keeping the date as a major thing and grouping by that def dot group by date. So the column it should be it's full of date. Next one is confirm the cases dot sum dot reset index, and next is that is stored in the total confirmed cases. So next is total death cases. In total death cases, so same in this df your data frame dot group by. So date will be your major thing. This the date part will be displayed, comma, that is a death count. It has been summed and it has been resetted. Okay. Let's see this. It's not an error. Okay. It has been executed. That's okay. Next is we are going to plot a graph now. Okay. So plot figure of so this is for your figure size variations. Okay. So this part. So how long or how it is visible to be, how big it want to be visible. To change the variation of x and y, this part will be used. That is plot dot figure. In this, the fixed size it should be that is 16, 10. Okay, this is your first line. Next is plot dot x. So the rotation of your graph is 90%. The font size it want to be visible in that is your 10 sizes. Okay, so the position of the graph or rotation of the graph is 90%. Next, I'm using this part plot dot plt dot plot. Okay, this will help you to plot in a graph. So total confirmed cases. Okay. total confirmed cases of date. Okay. In the previous statement, we have evaluated this. Okay. So the total confirmed cases of date dot dt dot date. Okay. So it has to convert the column into date format. So that's why I have mentioned here dot dt to date format. Okay. Next is, so by based on the date and also the confirmed cases, so the graph will be will appear. Okay. So total confirmed cases of date and dot dt dot date. Next is total confirmed cases of confirmed will be displayed. So the color it should be red and the label it has to be appear as confirmed. Next is the same as sort of total death cases. We have total death cases here. So in this, the same the date has been converted into the date format. Okay. So total death cases is of death. Okay. So the column here is so date comma confirm and date comma death cases. So the graph will be drawn by this format only. So the color I am using here is blue and label is death here. So plot dot x label, that is your dates, and plot dot y label is total confirmed cases. Okay, this is your total confirmed cases. So you are drawing graph with this. Next, the plot dot legend of location of 2. So what does it mean that you see that is legend of 2. So you just divide the graph into 4 parts. I will execute once again to make this graph smaller. Okay, you just imagine this graph. I'm dividing this complete graph into that is 4 quadrants. So this is your first quadrant, this is your second quadrant, this is your third and fourth. If you type legend is equal to 2 in the case, so your label will be appear in this corner. If we type legend is equal to 3, we will get here. Legend is equal to 4, you will get here. If the legend is equal to 1, you will be get here. Okay, that's they have to. So plot dot legend location is equal to 2 in the case. So this is your second quadrant. So in this part it will be displayed. So that's why the confirm and dead. These are the labels we have specified here. So this will be displayed in this legend. And finally we are showing the graph. We are executing. So this based on the date, the confirmed cases and death cases has been drawn here. I think so. The confirmed cases is red here. Okay, this is the confirmed cases. They up to this date, up to this January 1st. Yes. So January 1st and March. Okay. So up to this March. So the graph is here is that is confirmed cases. It's a red curve is a confirmed one and blue is a death count. Okay. So the graph is drawn based on the dates and also how much the cases has been increasing in the death and also in confirmed. Okay. I hope it is clear. So you can change the fixed size as you like. Okay, to do the visual appearance, how it should be. You can change the font size. Okay. So now I'm going to show the coding for that is specifically for India. Okay. For this, so DF of your country in this data frame, choose a country, DF of country. In that specifically choose an India. Okay. We are evaluating this part and storing in the coding India. Okay. Now we are going to group the column by India. This is India. In this, the India's data will be stored here. The India dot group by. Okay, group by in which manner we are going to the column should appear in the case first based on the data, so based on the date. First one is the column will be your date. Next is active column, confirm the column, recovered column, det dot sum dot reset index. Okay, these in this format the your data frame will look like. So this will execute it and store it in India. Now we are displaying this India.head. Okay. So here, this is the data. So we can check for India.tail here. Okay. So dot sum dot reset index. I already told this is the stack all the part and the position into the specific column and pasted in the specific column. So up to this April 28th data was there. Then, so up to this, we have calculated the India coding part. So in this next part, we are going to do a forecasting now only. These are the basic things, visualization, explorations we have seen so far. So now we are going to do a forecasting. Okay. For this, for forecasting, the term FP prompt has been used. We are using in this FP prophet, we are importing the prophet here. Okay. In this So this is developed by, it is created by Facebook actually. Web3 profile is created by Facebook actually. We are importing a profile. So this is specifically for forecasting the data. I am executing this df.head. So now this is our actual data we are having in the df.head. Next is df of your country, India. This is in the data frame. So the country which named India, it should be stored in df underscore India. So we are displaying this part. You'll see the output how it will be. Okay. So the country, so it should be India, completely India it does. Okay. So the latitude and the longitude, everything is there. Next is your confirmed cases. You are going to group the column visualization. So the data frame visualizations with based on the date is the major part and with the confirmed cases. So we are going to group by in this format. And after doing this part, is evaluation and storing it in the confirmed cases. This confirmed dot head. So confirm the top 5 data will be displayed here. So date is the one column and confirm is the second column here for you. Okay. In this, according to FP Prophet, so they have some concept here. If you just do a Google and search for the FP Prophet, you can able to see that. So we have to set the column as DS and one column as Y. Okay. In this scenario, the data column name it should be DS. Okay, and your name column will be your Y. Okay, your confirmed cases will be Y. So the variable which is defined by the active profile. So we have to keep the name by this one. We should not change the name. Okay, so they is defined by them. Okay, we should use this. So confirmed dot rename. Rename is option. I think we have seen before. So confirmed dot rename of columns. So which column? Okay, the column date. Okay, this column it should be changed as PS and the confirmed column. This column it should be changed as Y. Okay, after doing this part, it is stored in the confirmed here. You are executing the tail part, last 5 data. Okay, this is the last 5 data. So this is a count of the confirmed cases. Okay, up to 28, what is the confirmed cases? Okay. Next, we are building the model. So in this building the model, perfect interval width is equal to 0.95. Anyone can say what is 0.95 here? Any idea about 0.95? What is the interval width is equal to 0.95? Any idea? Okay, got one answer. Space between the two variables. Okay, okay, it's the nitrogen. Okay, I will say it as a interval dot width. Okay, interval underscore width is 0.95. Into this, 0.95 is a confidence level. So how far I can say this should be maximum level it can reach. Okay, I can say up to 95%. I can say this is best. Okay, so we can write 90 to 95% or 98%, but we cannot give 100% accuracy of forecast. I think no one can give in many programs. Okay, so maximum accuracy can give is that is up to starting from 90 to 95% we can give. 98 also can give. Okay, so it's just like an accuracy level, confidence level. Okay, so that is perfect. That is interval underscore with this 95%. So by this way, we are executing this part and storing in the model. This is a model for forecasting. Okay. Next is we are training the model here. In this model dot fit, I think I already told in the previous program, wherever you see the term fit, it is meant for that we are training the model. So you're training which part is that is confirmed. So trying to confirm the part. Next is so this model to be fit. The confirmed cases should fit inside the model because we based on the at last confirmed cases we can able to predict, we can able to forecast for the next 7 days or 10 days or something else. Next is for future days. This model should make a future data frames. So periods is equal to 7. Okay, we are going to do a future data frame. We are going to predict predict the future confirmed cases. Okay, so with a period of 7 days, I'm going to predict now. So this is the term inbuilt term make future data frame. So this is a inbuilt part inside this make future data frame and specifying the period that is equal to some count that is 7 or something else. So we are applying this part inside the model, and this complete part has been stored in the future dates we are executing. So now the future dates dot table. So the last 7 days has been executed. Okay, so up to 5. So up to 28 April was there. Okay, so 29, 30, 1, 2, 3, 4, 5, up to 5. So 7 period of 7. The date format has been displayed. Next is okay. We are going to forecast so with the future dates. So model dot predict. We are going to predict the future days. In future days, we have this values. We are predicting this. Okay. So next part is, and I will show this. So forecast of that is DS, Y hat lower, and Y hat upper. Okay. Okay, I will show one thing. So forecast. This forecast. we will we can able to see a large number of rows and columns here, like a DS, trend, Y hat lower, Y hat upper, trend lower, trend upper. Many columns are there actually, so that is not required for us. Okay. So we need here is so DS and Y hat, Y hat lower and Y hat upper. Okay. So the data is in here. I will execute this part and I will say, so this part is taken, Y hat lower, Y hat upper is taken. So Y hat is the value between Y hat lower and Y hat upper. Okay, so this is your confirmed cases with the future dates, with the future 7 days. These are the confirmed cases. So up to this April 5th, April 5th, sorry, May 5th. So May 5th, it will be the cases, confirmed cases will be, that is 38,068. Okay, this is the value between, you see this 36 uh, 1955 to 39,204. So in between this value is this 38. Okay, so we are showing this part. Okay, this is your Y hat lower and Y hat upper. Between this Y hat is displayed. So these are all here confirmed cases for the future 7 days. This is a forecasting method. I'm going to plot the graph. So model dot plot, I'm giving a complete data frame data of this data forecast that is stored in the confirmed plot. In this, you can see. So up to this point, so it is an already, that is confirmed cases with already predefined data. So the graph has been done. After this part is this plain line is there. So this part is that is a forecasted for 7 days. The confirmed cases forecasted for 7 days. Here this line, the slide variation is there. No, this is a Y hat lower and this part is Y hat upper. So in between this dark line is ZTP and Y hat. Okay. So the value what we have seen here, no, that is like 36,955. This is your Y hat lower and your upper value is 39,204. So your Y hat value is 38,016. So approximate, this is the approximation. This is not a 100% forecasting value. So we cannot give a 100% forecasting. So this is for sample programming scenario and for your training part, for project purpose, for everything else. So we can do an approximations. Okay, we can give a confidence level of for 95%. I have shown here it's like a interval, but so 95% confidence level can be given. Okay, this graph. So this is the concept of forecasting. It's COVID-19 forecasting. So by this way, we can take there is a real-time data of India, COVID-19 India, and we can do the process of India's forecasting. So I have done for India, but you can take the latest data and do this process. I think I have that also, COVID-19 India data also I am having with you. I will share that also. And if you want to take a data from the website, you can use a web scraping method. I think this is, you can try later with the example what I teached for you. You can try it with you. I think this is your website, Indian website. In this you can see this is your active cases, cured death cases, migrated one. I think this is, I'm not sure whether it is correct or not, but for testing purpose or something else, we can take this and do a thing. But I think migrated it has been remained same for so many days actually. The same thing is displayed here. Next, your state data. Okay. So this is your state data. So far, the values they have represented here is confirmed, the total death cases, everything here. So this data can be scrapped. Okay, can do a web scraping. So by web scraping, and after web scraping, and you can do a upload on your Google Colab and do a forecasting here. You can do this process also. And later, if you have chance, you can learn web scraping also. I will show the COVID-19 data for you, India's data. So I have done a web scraping here. Let's see. So by doing the web scraping, I have taken all the data here. So total cases, latitude and longitude. So latitude and longitude, we have to check for each state, and we have to plot it. Okay, this cannot be retrieved from the website. I will show it. So in the state data, I have taken by doing a web scraping, I have taken this. Finally, so after scrapping the data is I just format. Okay. But I have taken the additional values for latitude and longitude. Okay. So for each state, what will be the latitude and longitude? So by doing this, I will share this data to you. If possible, you can do that is you can do this part web scraping, and do a forecasting of this data. So which I teached for you with the help of this worldwide data, COVID worldwide data. The same scenario is followed in the COVID India data also. So, but here there are different in India, different state. What will be the confirmed cases, death cases, and recovered cases, and all. I hope any doubts on this? Any doubts? Any doubts from your side? Anything I have to repeat it again or something? Otherwise, you can. And one more thing I'd like to say, you can do a web scraping. That is in world-meter also. That is worldwide data. You want to go with the worldwide data. In WHO, they are also having a CSV file data set. Can do with data also the forecasting. Can do a forecasting, but the many data are available in the online. Can do with the any doubts? Any doubts?
Participants, if you have any queries, you can type it in the chat box. Okay, is it done then? Thank you, Gopika ma'am. That was a very wonderful session. I hope it will be very informative to our participant.
Yes. Thank
And
you.
your case study on COVID-19 is very impressive. It is
Yes.
very interesting for me to listen on it, ma'am. It was
Okay.
very
Thank you so much. Thank you so much. I thought
participants.
applying the COVID 19 orders in India area also, but due to the time constraint, I cannot able to do that. But I thought I explained some of the web scrapping also. If I say some of the web scrapping, they can able to do it by their own. If they want to do some future forecasting in different data sets, they can do it by their own. So I thought that also. Okay. I hope this session is very interesting. I hope I don't know the participant has to answer for me.
Yeah, ma'am. Uh, Participants can give your feedback. Okay, if you're willing to give your feedback, you can raise your hand so that I can unmute you, sir. I can unmute you. So you can give the feedback for this 5 days FDP. Sorry, 5 days workshop. Dear participant, can give your feedback. Okay, no one is rising.
Okay, no issues. I think
Okay.
they are very busy with their coding part or something else. So it's good to they have typed already. It's good enough actually.
Okay, ma'am.
Okay, very thank you, ma'am. Thanks for
Thank you,
giving
ma'am.
this
Thank
great
you, ma'am.
opportunity for me and for organizers, Priya and Kalimani. So very thank you to both of them. I hope this session is interesting and useful. I think so. Okay, thank you so much.
Okay.
Okay.
Dear participants, is a time for a vote of thanks. It gives me a very great pleasure for proposing the vote of thanks for the workshop on data science using Python. First, I express my sincere thanks to our management, principal sir, vice principal man, and dean of academics for their continuous support and ready assistance rendered for making this event a grand success. I thank you all. I render my heartfelt thanks on behalf of our management, our department, and all participants to our resource persons of this 5-day event. Day 1 is handled by Mr. V. Kovindan sir, day 2 by Mr. M. Kannan, and day 3 by myself. Sorry, day 3 by myself, and day 4 by Mr. M. Kannan, and day 5 by Ms. S. Gobika ma'am. I thank them all. I hope all the participants had a great and informative session. Thank you all. And I extend my sincere thanks to our head of the department and all other staff members of our department for their support and cooperation. Thank you all. And I also extend my thankfulness to all the participants from various colleges who made this event a grand success. Thank you all. Also, I would like to thank the persons behind the technical support and all others who have contributed directly or indirectly for the successful conduct of this function. Thank you all. Once again, I thank you all. Thank you for your cooperation.
Thank you.
A small, thank you, ma'am.
Thanks to the college and the Arasu Engineering for conducting this session. Today, it was a very good opportunity for me to interact and share the concepts with me. So thank you so much, all. And to the participant for your there is a for patience, especially for the patience for these 2 hours. Thank you.
Okay, thank you, ma'am. A small announcement to the participant. I'll be posting the attendance and quiz link for today's session shortly. Followed by that, I'll be posting the feedback link. I request the participant to make sure the correctness of your name and the institution in the feedback form. So that feedback form will be used for your certificate purpose. And the certificates will be issued within a week time because we are going to generate the certificate manually after verifying your attendance for 5-day session. Okay. Kindly fill the feedback form with proper name and the institution name. Okay. Corrections in your certificates, it's not entertained because we are going to generate it manually. So make sure you're not making any mistakes in filling the feedback form. Okay. The links for the quiz and the attendance as well as a feedback form will be posted in a half an hour of time. Any issues or any queries, just you can ping me in the WhatsApp. Thank you all.